Trigonometric functions of real numbers. So hopefully you went through that chart, filled it all out. If not, we'll be addressing it again today, so hopefully it'll help you. So let's go through the basics of trigonometry that you're supposed to know. Sohcahtoa is the easy way of remembering what each one is. What's the sine? Opposite over hypotenuse. Except in a unit circle, and it's always from the origin, the sine of theta. Opposite, this leg here is your opposite. This is always going to be y. The adjacent is always going to be x. And r is your hypotenuse. That's always going to be 1. In the unit circle, we're never up here at the circle looking the other direction. Okay? So as the circle goes around, your opposite leg is always your y, and your adjacent leg is always your x. Okay? Alright, so opposite, the sine of theta, the opposite leg is y over the hypotenuse, y over 1. Or the sine is just y. The y value of your coordinate, that's all it is, because the hypotenuse in the unit circle is always 1. Alright, so this is important for the other things we're going to show you. Leave a little space here. The cosine of theta is what? Adjacent over hypotenuse. And again, in the unit circle, you have x over r, or x over 1, which is just x. Again, so when we're dealing with the coordinates, the x value is your cosine value. And then we have tangent, leave a little space. Tangent is what? Opposite over adjacent, very good. You all done a little bit of homework. So this is y over x. Oops. Yeah, that's right. Sine over cosine. That's something you should not forget. Unit circle, tangent is sine over cosine. Y over x. Alright. What goes hand in hand with sine is the cosecant. It doesn't go with the cosine. Cosecant does not go with cosine. It goes with the sine. So that's how you can remember. A lot of times we're going to say, well, cosecant goes with cosine because it starts the same. It has nothing to do with it. Cosecant goes with the sine. And that is 1 over sine. It is the reciprocal of what you have for the sine. Or in this case, 1 over y. The secant is what goes with the cosine. And again, it's the reciprocals. 1 over cosine or 1 over x. And cotangent goes with the tangent. That's easy. So the cotangent goes with tangent, cosecant goes with sine, secant goes with the cosine. So the cotangent of theta is going to be the adjacent over the opposite, or 1 over tangent, which is x over y. Sorry, that's kind of low there. X over y. You should definitely remember that cosecant is 1 over sine, that the secant is 1 over the cosine, and the cotangent is 1 over tangent. All of this that's on here is used when we're trying to figure problems out algebraically. Manipulating how they look. That's what we're going to do today. We're going to manipulate certain things. We've been building up to it. This is extremely important. Alright, something else. And then we'll get to kind of what that chart's talking about and do a couple more examples that's not on your chart, which hopefully by now you've struggled through, you've gotten frustrated, you've gotten friends to help you, and you realize, okay, this is really all it is. Now I can give you something else that's not on that chart, and you should be able to figure it out. let's go back to this for a second. This is a right triangle. What do we know about right triangles before you came into this class? Yeah, they're 90 degrees. That's right. Huh?
36,
Or 189, 90?
Sure.
Okay, I mean, those angles don't mean anything. Pythagorean theorem, okay? A squared plus B squared equals C squared. In this case, A, B, C. X squared plus Y squared equals 1 squared. What's another thing for X? Cosine. Thank you. Cosine squared plus sine squared equals 1. Obviously, cosine squared of theta plus sine squared of theta. Cosine squared of t, sine squared of t, whatever it is that we have there. That is a formula you need to remember. There's another one, tangent squared plus 1 equals secant squared. And there's another one in your book. You guys can look them up. But let me just show you where this tangent, the tangent squared plus 1 equals secant squared comes from. It's like the completing the square formula. You don't really care where it came from. You just want to know how to use it. I'm going to show you where this came from. You don't need to know that. It's just for your own personal benefit. Tangent squared is the same thing as, where's that? Sine over cosine. Tangent same as sine over cosine. That's sine squared over cosine squared. That's the same thing as tangent squared. Plus 1. Secant is the same thing as cosine. 1 over the cosine. So this is 1 over cosine squared. What's my common denominator? Cosine squared. 1 is the same thing as cosine squared over cosine squared. What do you do when all your denominators are the same?
Cancel them out.
Cancel them out, because I can multiply by cosine squared and they'll cancel, alright? So what am I left with? They don't ever write it like this, they write it as sine squared first for some reason. So I didn't really dive into the history of it very much. So it's always written as sine squared plus cosine squared equals 1. So my point is, this is all the same thing, they just use different trigonometric functions. And there's another one in your book that I expect you to know. Okay? So make sure you have those and you memorize them. Make sure you know this. If you don't know it, memorize it. It'd be best if you knew it instead of just memorizing it. And doing these charts helps you to do that. Alright, I'm going to do a couple of these first few problems in here. This is not on your chart, but it's exactly what you did on your chart. So if let's pick the sine of 11 pi over 6. Find the exact value of the trigonometric function at the given real number. Okay? This is what I see when I look at this problem, and the same thing you should have been thinking of when you did your charts. The first thing I see is this is pi over 6. What is pi over 6? 30 degrees. And what is 30 times 11? 330. So right now I'm thinking in my brain the sine of 330 degrees. The next thing I think of is the visualization of it. There's 180, 270. How much more do I need? 60 more, which is really the reference of a 30-degree angle. There's 330 degrees. That's what I'm thinking. So now I want the coordinate of that point. What is the coordinate of that point?
Where'd you get the 330?
Pi over 6 is 30 degrees. 30 times 11 is 330 degrees. Okay? So I'm converting all this stuff into degrees into my head and drawing a circle on the unit circle to find out where I'm at. So, again, the only values you need for your unit circle are 1/2, the square root of 2 over 2, and the square root of 3 over 2. This is your short leg, that's your long leg, and this is always your 45-degree angle. That's how you remember those. So what I have here is a 30-degree angle. What is my y? Because sine is just y. It's the y coordinate of all these that we're looking at all the way around the unit circle. If I ask for the sine, I'm asking for the y coordinate. What? Negative 1/2. Why is it negative? Because it's in the third quadrant, and that's the bottom part of that chart you had. What is the sine value in the third quadrant? Well, it's the y value, so in the third quadrant, or excuse me, fourth quadrant, it's always negative, and also in the third quadrant. So when you're doing that chart, that's important to know what those are. Especially, even in Chapter 6, as I'm going through and getting ready to teach you that stuff, we still need to know what those values are as far as positive and negative. So the more frequently we do this, the faster you're going to be able to answer these questions. Okay, let's do another one. Let's do, I'm trying to find something odd. Cotangent of 25 pi over 2. I'll let you that one. How about the cosecant of 7 pi over 3? Again, let me walk you through what I'm doing. Do you want to try it by yourself?
Yeah.
Alright, try it by yourself. Pi over 3. You should have gotten this far by now. That's 60 times 7. Making a 420 degrees. Where does that end up on the unit circle? 360 is all the way around once. All right. There's 360 plus 60 more is going to give me 420. There's 420 degrees, which is really just a 60-degree angle. So on the unit circle, this coordinate, this is the short leg, this is your long leg. Okay, that coordinate is going to be 1/2 square root of 3 over 2. And the question is, what is cosecant? Cosecant is 1 over y. So the y value, 1 over the square root of 3 over 2. How do I deal with that? One times the reciprocal, or just the reciprocal at the bottom. 2 over the square root of 3, so we need to rationalize that. 2 radical 3 over 3, good. Alright, so there's a whole bunch of these in the beginning of your assignment. I'm only giving you every other odd, so make sure if you're struggling with it when you're done, every other odd. Make sure when you're struggling with it that you do more. You need to be proficient at it. Alright, now let's go on and do something else here. This is number 30 in your book, and I'm just going to read through some of the instructions to make sure we have this. The terminal point is given, which I'll give you here in a second, determined by a real number t. Find sine, cosine, and tangent. Alright, so example 30. Here's your terminal point, negative 3/5 and 4/5. I want the sine, the cosine, and the tangent. Now, you must show me first before you tell me what the sine, the cosine, and tangent are, you must verify that this is on the unit circle. And how you do that is with those formulas over here. The sine squared plus the cosine squared equals 1. Because what we've learned is sine is y and cosine is x. So this is your sine and this is cosine, but only if it's on the unit circle. So if this doesn't work, then it's not on the unit circle. You can't say the sine is 4/5 and the cosine is -3/5. Okay? So what we're going to do is 4/5 squared plus -3/5 squared equals 1. Verify that. Make sure that's correct. What is 4/5 squared? 16/25. What's -3/5 squared? 9/25. That's 25/25. It does equal 1. Alright, so therefore, the sine is 4/5, the cosine is -3/5. What's the tangent? Tangent of t, what is it? How do you find it? What's it say over there? Sine over cosine. So 4/5 divided by -3/5. So 4/5 times the reciprocal of the bottom, -5/3. You get -4/3. So you must do this on that set of problems. You must verify that it is on the unit circle, and then you can tell me what cosine, sine, tangent are. And this is the beginning of you having to do a whole bunch of figuring, okay? But it's not difficult, you just have to work your way through it. Okay. Another one of those? Sure. Let's see, how about 32? And 1/3, -2 radical 3 over 3. Okay? Again, this should be sine and this should be cosine. Cosine is x, sine is y. Square them both, add them together, see if you get 1. This over here. Sorry, put the wrong number in there. Just relax. So if you have this, you can say it's not on the unit circle. You don't get it. You don't have to erase it. You can say that. Okay. So it does work. If you write down the problem, probably answer. Right problems.
It's not going to end up as 1.
I'm not going to tell you that. You do have the answers, so you can look. Alright, so this is it. So your sine is -2 radical 3 over radical 2 is what it was. Radical 2 over 3. Your cosine is -1/3, and your tangent is sine over cosine. So negative over negative is positive, 2 radical 2 over 3, and 1 over 3. The 3's are going to cancel. Your answer is 2 radical 2. Is that what you got? As you read it, sorry. Alright, I need to show you something that's in the book. I'm talking about Radian Measure. Put it on the screen here so you can see it. There's just a few of these problems. It's pretty simple once we talk about it. Let me refocus it real quick. This measurement around a circle is 2 pi. Halfway around is pi, which is what? What's pi as a number?
22 over 7.
3.14 something.
I thought you wanted degrees.
Okay, 180 degrees. But each one of these is a 10. 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. All the way around, this is pi, which is 3.14. 2 pi is going to be 6.28. Okay? So that's what these hash marks are. These hash marks are all by tenths. Okay? What it's asking is find an approximate value of the given trigonometric function, the sine of 1. Okay? So basically what I want is the y value of that coordinate. Well, what is that? You notice I have lines drawn on here. Notice it's a little bit above that point. So what is this? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. That's x. The y value is this right here. 1, 2, 3, 4, 5, 6, 7, 0.8 something. I'm approximating. So the sine of 1 is just my y value, 0.8. All you're doing is looking for either x and y or a combination of them for like tangent. Okay? But you got to be able to tell me what the coordinates are of any of these points around here. So now, we approximated it. Let's use our calculators. Now what are we finding? Are we finding the sine of a degree? No, we're finding the radian measure. So everybody turn your calculators on. Turn your calculators on. Hit mode. Go down to radian and hit enter. You need to be in radian mode. And then hit second quit. Now hit sine of 1. And that'll give it to you exactly. Okay, now go into mode again, take it off, put it on degree. Hit second quit. Hit sine of 1 again. If you don't know whether you're finding radian measure, the sine of a radian, or sine of degree, then we got big problems. You got to be able to tell me if you're finding degree measurement or radian measurement, okay? So you got to be able to go back and forth on your calculator. If you do the wrong thing, you're going to miss a lot of problems, aren't you? Alright, so make sure you pay attention in your answer book to what you're doing. Make sure you understand what it is you're doing. You're finding degree measurement, you're finding radian measurement. Alright, that was it for that. So when you get to that part of your book, make sure you're in radian mode. Alright, since we have the book up there, I'll just let's talk a second about a couple more things and then we'll take a quiz. Okay. Find the sine of the expression if the terminal point determined by t is in the given quadrant. This is the sine of t times the cosine of t. This is the tangent of t times the secant of t. Well, let's do this one since we've not dealt with that other formula. So here we have tangent of t times the secant of t, and it's in quadrant 4. We got the sign of the expression. We're in quadrant 4 here, right here. All of these are here. What are all my y values?
Negative.
They're all negative. The tangent is y over x, isn't it? Alright, all my y values are negative. What are all my x values? They're positive. What is the tangent in the fourth quadrant?
Negative.
Negative. Negative or positive is negative. That was in that chart. The fourth quadrant wasn't, but you ought to be, well, yeah, it was at the bottom. We did all 4 quadrants. So you ought to be able to make sure you understand those things, not just from the chart, just in general looking at y's and x's. All right, secant. What is the secant?
Reciprocal of the cosine.
Reciprocal of the cosine. 1 over cosine, 1 over x. What's that? What did you say x was? In the fourth quadrant. Positive. Well, what's 1 over positive? Positive. So we have the tangent being negative, the secant being positive. What's the tangent times the secant going to be? Going to be negative. That's all it was asking. So now we're just thinking. We're trying to get you proficient with understanding values of trigonometric functions before we can actually start running with this information. Look at this bottom part down here. From the information given, find the quadrant in which the terminal point determined by t lies. Tangent has to be positive and the sine is negative. So now it comes down to, let's just think quickly. The sine is y. Where is y negative? In the third quadrant and the fourth quadrant. Y is negative, right? I started with that just because that was easy. The tangent is positive. Tangent is x, y over x. The tangent has to be positive. So either we get a negative over a negative or a positive over a positive. For the tangent to be positive, this is what you have. Where is y and x both negative? In the third quadrant. Where is y and x both positive? In the first quadrant. Where do they overlap? Right here. The tangent and the sine. They overlap right here. So this must be the quadrant we're talking about. So the sine is negative in both these quadrants. The tangent is positive in this quadrant and this quadrant. So where are they both together the same with what this is asking? In the third quadrant. Okay? I'm going to do another one. Okay? Let's do this one since it's circled. Cosine of t is negative. So on a circle, cosine is represented by x. Where's x negative? What quadrants? The second and the third. Now the second part of this, the cotangent is x over y. And it has to be negative. So either the x is negative and the y positive, or the x is positive and the y is negative. Now we really got to think. Let's do this first part. Where's x negative and y positive? Second quadrant. Where's x positive and y negative? Fourth quadrant. All right, where do they overlap? Right there. Does that help? You'll have to just think through the others. But notice what I'm doing here. I'm just looking at the x's and y's of these trigonometric functions and asking where are they positive and negative. It does take some time to think about it. All right, let's move on. Time for one more? Right? The first expression in terms of the second. We've had this forever. Right? Y in terms of x. That just means solve for y. Write cosine in terms of sine. That means solve for cosine. Cosine squared plus sine squared equals 1. How do I solve for the cosine?
Subtract the
Subtract the sine. So cosine squared equals 1 minus the sine squared. How do I get rid of the square?
square root.
Take the square root. Cosine is plus or minus the square root of 1 minus sine squared. Quadrant 4 is the cosine is x, positive or negative, in the fourth quadrant. Fourth quadrant is x positive or negative. 50-50 chance, positive, that's right. Positive square root of 1 minus sine squared. That's why that's it. So you're going to use these formulas, the 3 formulas that are in your book. Make sure you got it, alright? I think we have time to look at another set of directions. Find the values of the trigonometric function. So you're going to find all of these here. Cosine of t is negative 4/5. Squared plus sine squared equals 1. I'm using the formulas to solve for the other trigonometric functions. If they give me sine or cosine, I'm going to use this. If they give me secant, cosecant, I'm probably going to use this as well. I might use the tangent squared plus 1 equals secant squared. Use the 3 formulas that are in your book to help you find the other numbers, the other trigonometric functions. So how do I solve for sine squared? Subtract this. This is 16/25. So sine squared equals 1 minus 16/25, which is what? 9/25. So the sine squared equals 9/25. Now what do I do? Square root of both sides. What do I get? Plus or minus 3/5. Now which one is it? I'm in the third quadrant. The sine is your y value. What is your y value in your third quadrant?
Negative.
Negative. So my trigonometric function is negative 3/5 for sine. Cosine is negative 4/5. The sine is negative 3/5. That makes sense? Cosine is x, sine is y. In the third quadrant, they're both negative. X and y are negative in the third quadrant. Yeah, you just, guys, it just takes some time to think through each problem. You will get faster at it. Alright, quiz time.